Hello.
Good morning, or, afternoon, or middle of the night, evening. So apparently folks are having a hard time logging into well, either to Data Tracker or to the integration with MeetEcho. So maybe let's give them a couple more minutes to enter the meeting. Since Mike asked on the chat, this is just making sure that audio works. Can someone confirm on the chat that you can hear me?
We can hear you just fine, David.
Great, thanks. Yeah, we're still waiting on some more participants to get through. I am seeing Victor. All right, then I think maybe at this point we can get started. Bernard, what do you think?
Yeah, I think it looks like the logjam has been broken. We just added like 20 people in the last minute or two.
Okay, good. All right.
Okay, thank you. This is the IETF 112 meeting of the WebTrans Working Group. A few meeting tips. This session is being recorded. A data tracker login is required to attend. I know a bunch of you have had problems with that, but hopefully you're through it now. You don't have to fill in the blue sheets, that's automatic. You can join the Jabber Room via the data tracker meeting agenda. Please use headphones or an echo canceling speakerphone and state your full name before speaking so we can get you in the minutes. So we are going to be running a queue. I guess, David, you'll run the queue. And this is a little bit of advice on how to get into it and out of it. You use basically the hand tool, and then you'll need to enable your audio or you'll be talking while muted. You can enable video, you don't have to. It does help a little bit with the comprehension, but it isn't required. So the note well, this is an IETF working group, so IETF policies are in effect. And by participating, you agree to follow those processes. Definitive information is in the BCPs below in this slide, and we encourage you to read them and understand them. And also, of course, personal information you provide is handled in accordance with the privacy statement. Also, we'd like to be clear that the IETF meetings, virtual meetings, mailing lists, etc., are intended for professional collaboration, and we have IETF guidelines for conduct, anti-harassment, and the procedures for the same. If you have any concerns about anything you're observing, please talk to the Ombuds team. We're available for you, and you can do that confidentially. And of course, we strive to maintain an environment which exemplifies dignity, decency, and respect, and we expect you to do the same. So a little bit about the meeting. The agenda is up on the web. We also have the notes segment is enabled in a Jabber room. I guess Alan has volunteered to be the Jabber scribe. We are looking for note takers and would like to solicit volunteers for that. Do we have volunteers for taking notes in the Notes app?
As a reminder to folks, taking notes is not very hard. They don't need to be perfect because we have the video. They're mainly to capture decisions, and we can't start meeting without a volunteer. So please volunteer to come and help us take notes.
Well, I guess we can try drafting people if they won't volunteer. We really do need a note taker.
I see James volunteered in the chats. Thank you so much, James. Much
Thank you.
appreciated. We have a second person as well to assist. Secondary is even less work.
This is Spencer. I can do that. I can help James as well.
Thank you
Awesome.
very much, Spencer. Thank you very much.
Both of you.
Okay, so some other meetings this week, which you may be interested in. There's a media over quick side meetings. And if you go to the link above, you'll see when they are. There's one today, a little bit later. And there's another one on Friday, so I encourage you to have a look at those. They will be talking about some of the issues of transporting media over QUIC or web transport. Okay, so the agenda, we're mostly through the preliminaries, thankfully. We should do the agenda bash, but here's basically what we have on store for you. We have a web transport update from the W3C. Jan Ivar will do that. We then have Victor talking about web transport over HTTP3 and Eric talking about web transport over HTTP2. And then we'll have our wrap up and summary. Is there anything else that anybody wants to put on the agenda? Okay, not hearing any suggested modifications. I'm going to turn it over to Jan Ivar for the W3C web transport update. Jan Ivar.
All right, can you hear me?
We can.
All right, great. So this is an update from the W3C Web Transport Working Group with progress we made since last IETF111 on July 30th. The status is now we published another working draft, which means we're technically no longer first public working draft, we're just working draft, so yay. We believe we finished all discussion of issues in our minimum viable ship milestone that we advertised last time. There are 4 non-editorial issues remaining that are ready for PR, but we believe they are not controversial, and 3 editorial and a tracker for web platform tests, which have been added. Some decisions and PRs, we shored up error handling in the algorithms, and there's a new web transport error DOM exception with the following members. There's a source to say whether the source of the error is stream or session being the entire connection. And with also an 8-bit stream error code that defaults to 0. This means that upstream of a sender even, you can now abort a WhatWG stream with a new web transport error, and you could specify stream error code that will be sent to the receiver. There's also a max datagram size read-only member on datagrams that is a user agent implementation defined integer you can query. There's also sender side now takes streams of buffer source objects as input, which means array buffer or array buffer view. We added in minimal prioritization, which means that all outgoing datagrams have priority over other outgoing data, like in other streams. We added a 32-bit closed code, which is not an error, but we can await the web transport closed promise with a recent string as well. Next slide. We also had an annual TPAC meeting, October 26th. Slides are available in the link here. We highlighted differences for those coming from a WebSocket background and also from a WebRTC background to try to give a broader overview for people of web transport. We also highlighted a Chrome update. They are shipping web transport in M97, which is built on the 02 version of the draft and has support for 8-bit reset stream code and I believe 32-bit closing error code. No origin rich trial is required. This is fully shipped, available in window and workers, only secure context. Some things that still need to be added are, deeper prioritization of sending and stats. Also, the hash-based certificates instead of web PKI may be available in 98, it was said. Implementation is fairly mature, covered by web platform tests, using an echo server based on AIO Quick. Also, a presentation was made by a member for multicast for the web from the W3C multicast community group with a demo. And they made a request to the I should clarify, the member made a request to the W3C to add multicast datagrams as a use case. And so the W3C is not requesting this, but we're forwarding that request for consideration by this working group because it's more network related. Next slide. Also, an issue was identified around bidirectional server-based video conferencing and low latency video upload from client to server. So this is an important use case for us, and we've seen some evidence that better integration between encoder and congestion control algorithms can be helpful. Not sufficient stats APIs are not available today in web transport to do that well, we believe. Web codecs API for average bitrate target, for instance, can result in overshoots when keyframes are sent and undershoots for delta frames. While an application can always send less what the congestion window will allow, it's not really easy to send more than the congestion window permits, because what you want to do probably is like additive increase to probe for more network availability. However, that doesn't allow you to re-enable drop layers, which would be a multiplicative increase. So with that application filling the congestion window by probing, the sender can practically get stuck in an artificially low rate. And there's also some conflicts, potential conflicts with other congestion controls being discussed, such as this paper on RTP over quick. So the W3C working group is requesting that this working group support this use case because it's an important use case, and help us develop measurements that can be used to do this more effectively. And that's it. Thank you.
Okay, thank you, Yanivar. I would note that some of this is being discussed now on the Media over Quick mailing list. And with respect to RTP over Quick, there will be a discussion in AVT Core later in the week. Okay, so we're going to hand it over to Victor to talk about Web Transport over HTTP3. Victor?
Hello, can you hear me?
We can.
Okay, so I'm going to give update over Web Transport over H3 as well to go over some issues. I don't expect this to go over too long because most of the issues are either the easy issues were addressed and the hard issues require more discussion that this meeting is likely to fit. Next slide. So let's start with there is a new version of Draft 02. It incorporates like months, like 6 months worth of changes to the draft, and it includes the clean close of entire session, reset error codes, and a bunch of other stuff. And this is the version that is in its non-pooled incarnation shipping in Chrome 97, which means at least we, as a Chrome team, would have to maintain it for quite a while. Next slide. So one of the details which I had to add because I realized we don't have anything like that is we added a header that indicates the version of the draft you're using. It is intentionally framed in the draft version, and it will and we will likely reshape it or remove it when we ship the final version. But this is how it looks right now. Next slide. So let's move on to the issues. As I said, I didn't put that many issues on the slides because most of them are either closed or require more effort. Next slide. So the first issue we kind of discussed in past but never came to conclusion is how do we need a mechanism for draining sessions gracefully that is equivalent of a go away frame for web one sec. That is to say, do we need anything like a go away frame? And the reason we would want it for individual session is that we have similar capabilities in protocols like H3 and people have expressed interest. I guess the people who expressed interest are Luke and Alan. So I wonder if either of you still thinks that's useful or can elaborate on what you think about this. Alan.
Yeah, this is Alan Frindell. I'm still inclined to say there is value in having a go away capsule. Well, capsule may be a loaded term based on what's going on from yesterday. But as long as there's a structured way to send messages over the extended Connect stream, then it seems very lightweight to be able to add a message like go away. And we've seen lots of examples of people building protocols without things like go away, and it causes a bunch of problems for servers that want to drain gracefully. And anybody who would want it, I mean, you can always sort of build it yourself by adding a control stream inside your web transport session and defining your own framing, but it seems much cheaper for us to add a mechanism for it. Martin will argue with me.
Martin.
In this case, I'm not sure what the semantics you would attach to a go away would be. It's going to depend on the application that's using the web transport, isn't it?
Okay, waiting for audio. Yeah, I mean, it can be a signal that just says, but it signals just an intention, like, I would like this to go away soon, and can include information like, and the last set of whatever streams I received anyway, can be identified by these numbers. And what the semantics are, you're right, are sort of dependent on whatever protocol is running over top, but I think the high level signal is still valuable.
Yeah, I guess what I was getting at there was if there is a generic signal, then it wouldn't really make a whole lot of sense to attach anything to it, because the concepts that an application uses, the sort of granularity of its stream usage and datagram usage is unknown and unknowable. I
agree with what you're saying. I think the information you can include is information that is exposed at the to the web transport, which is like, I have seen these stream identifiers, like they have at least been whatever, like passed to the application. But everything else, I guess it's certainly possible the application has higher level semantics, and that it would need to convey beyond what's in the transport, in which case they have to write their own frame anyway.
Okay, yep, that makes sense.
Another possibility is that I'm not sure if we've defined on the Connect stream, is it okay to have unknown capsules and people could use that Connect stream as a control stream? Or are the messages on the Connect stream only the ones defined in the standard? And if you want to send any other messages, which are session level messages, they have to go over some stream that your application controls.
I guess to the later comment about messages, I think that capsules are to some extent not controlled by application, because they're in some sense privileged, as in we assume they come from the browser and not from the web application. In that sense, we can't really give you the full control. But also in general, my intuition is we should not add new concepts which are already trivially achievable with the APIs we give, because this just like adds multiple ways to do things that are somewhat redundant.
I don't know that how trivial it is, or if it's, because there may be applications that don't use or need a control stream. I don't know. And so, and requiring every application to do it. I guess we had this discussion, 4 years ago in Quick, when someone tried to add go away. Originally go away was a quick frame. And then we said, no, make every application do it. And now we have. So I guess maybe the same principles apply here. I don't know. I still think like signaling the intent and capturing transport level information to the other side about what's been received is a building block that can be reused and it's low cost. But I don't know. I don't need to die on this hill either if people feel strongly that it's the other way.
All right. Thank you, Lucas.
Hello. So I think I was agreeing with Martin's earlier point that the value of this thing, go away, whatever you want to call it, depends on what information it includes and what the receiver would act upon. So I think I don't understand really what this adds above HTTP3 go away, and what it would include that's generic enough that anything else at the web transport layer would be able to read that and act on it. So maybe there is if someone has a proposal, but right now it kind of seems like impossible to define and implement in a way that would work for everything to me.
Eric Negrin.
I guess the benefit of doing this in the at this layer would be if there was an intermediate that wanted to go and send that, send it to both of the endpoints, but without knowing the inner protocol the endpoints were using, such as like if you had a CDN that had implemented web transport. The alternative may be on the API side, if the API exposed up to the H2 or H3 go away as part of the web transport API, but I'm not sure which is going to be cleaner from a just only keep it at the H2, H3 layer, or also have a way to send go away through a capsule or capsule equivalent.
Alan?
Yeah, I think the context is like paging in after months and it being 4 a.m. The intermediary case, I think, is the one where it's useful because you may have, first of all, the intermediary that is sort of proxying web transport without understanding the underlying protocol, and it wants to go away, and it needs to tell both endpoint, like it's got a web transport session going in each direction, and it wants to tell both of them that it's going away, and it may be using pooling. So I guess in that case, the HTTP3 level go away is probably sufficient, but there may also be cases where somebody wants to make there are pooled web transport sessions and I want one session to go away, but not other sessions or other HTTP requests that are on the same connection, which is why it would be a session specific message rather than a connection specific message.
All right. I think my main question, it sounds like we need a specific proposal that explains the use cases that this is for. And my question would be, Alan, would you volunteer to write a PR or a proposal for how to handle go-aways in web transport over HTTP3?
Yeah, I can write a PR, and people can argue about it. We can repeat our arguments here on the PR.
All right. Could either of the chairs record it on the issue while I move to the next slide? Or someone? Next slide.
I'll record it. Go ahead.
Thank you, David. Now, here is an interesting issue that we have historically just punted until later, and the later is kind of approaching. And that is, at some point, we agreed that it would be useful to support pooling of multiple web transport sessions, or with each other and with regular HTTP3 traffic. And in order to do that, we need to have some understanding of how to do resource management, namely, how do we limit, namely, Quick provides flow control for all of the resources, but the flow control is it's connection global, and the pooling is between sessions that are in some sense not related to each other. And in ideal scenario, we would strongly prefer to isolate the sessions in a sense that even if one session misbehaves and acts in a way that starves itself of a connection, it does not starve others of resources. And the question is, how do we do that? And currently, there are no specific proposals in, at least the ones I'm aware of. So I was wondering if we can at least start the discussion here, and I want to, do people have opinions or ideas about this? Martin.
For someone to say something. Okay. So last time we talked about this, you raised the point that we essentially give sites the ability to use fetch to consume all of the available bidirectional stream resources for a connection, sort of almost without constraint. And we sort of assume that there's enough resources there that they can do that if they so choose. And the more that I think about this, the more that I think that that sort of laissez-faire attitude toward this thing might actually be the best solution, at least for the meantime. It doesn't mean that we might not choose later to do something, but maybe we can just do nothing for the moment.
That is definitely a possible approach we can take.
Document it.
Yes. The cases, I'm afraid, are the pathological interactions that are novel to web transport. For instance, your web transport opens so many streams that you cannot fetch it all.
Yeah, that seems entirely possible, particularly given some of the patterns that Yanivar has shared with us.
And it is not entirely clear to me that such patterns would be possible with fetch, because fetch is a more complicated structure and it has its own limitations and things.
Yeah, don't make claims like that, because that's just a challenge.
Yes. Well, I am not challenging to intentionally do that. I am saying, I'm talking about likelihood of that occurring unintentionally.
Right.
Spencer.
Thank you. And I was actually just following up with Martin. Do you think that the laissez-faire attitude would be easier to add, or to add later, or to take away later?
I don't think it's particularly difficult to add some controls. I think it's pretty difficult to add them in such a way that they would be reliable and such that you could depend on them being there and depend on them being effective. So if there's something that was truly bad going on and things were breaking, I don't think you could rely entirely on whatever mechanism that you introduced. But that's just guessing. I'd have to sort of think about what sort of system that you might want to introduce. I've got no good ideas at the moment, unfortunately.
Okay, thank you.
Lucas.
Hello. I was just reading up on the issue, which is like a year old, so my memory's a bit hazy, but it kind of seems a bit similar to a discussion we were having a few weeks ago on the HTTP priorities draft, unrelated to priorities, but around the ability for endpoints to detect how many concurrent streams they might be able to open, or that they gave to the peer to be able to open. Some of that hinges on the quick API that is exposed up to applications, and that you should assume that the API gives you all the information you need to know, but that assumption maybe doesn't hold for different implementations. So I think, like, if we look at it from a perspective of trying to avoid a client consuming all of the concurrent request streams or bidirectional streams it could open, like I honestly, I don't know if we can assume that that information is available directly to clients, but that if it was in some way, that there seems to be, to me, an API issue, not a protocol one, such as you could say at the browser level, just ask for a share of the available connection resource for concurrent streams that the server would let you open, because you're not going to know that information until you create the connection, and that could vary by server. So I don't know. I don't think there's much we could do here, but I could be wrong, and I'm happy to be wrong.
Thank you, Lucas. Yutaka.
Can you hear me?
Yes.
So ideally, the memory consumed in the connection should be a function of the bandwidth. So that even if we have many streams, the bytes transmitted per second shouldn't increase by creating more streams. So with ideal implementation, the constant memory should be enough. Is that right?
That is to some extent correct, but there is also the issue of not just limiting the buffer size, but also the total number of streams.
Mm-hmm.
In fact, this is like more of my main concerns, is that their Quick has some limit of how many streams you can open on the same HTTP3 connection, and that limit is shared between regular fetch requests and web transport in the situation when there is pooling. So the problem here is, how do we make sure that we don't open too many web transports so we are incapable of doing fetch, and vice versa. Thank you. Dragana.
Hi, you hear me? Do you hear me?
Yes.
Yeah, okay. Sorry, I haven't used that often. I'm afraid of different implementation having different limits, and this really being the timing issue, that page is opening and there is a lot of fetches, and then they cannot open the streams, and this is like timing dependent, that for application developer can be pretty tricky to like notice the problems by testing. I'm wondering, this is like going far away, like in the different direction. I'm wondering of having the guarantees about the limits per web transport session to make this debuggable. But this is like opening the different kind of issues around that.
I agree that we should have give developers some idea of what they should at least expect the browser to support, because if my web transport only supports 4 concurrent streams, that's a very different situation if it supports 100, and that would to some extent affect even the fundamentally how I design protocol. So
Yeah, I'm just wondering about the pooling behaviors, different browser engines, that there are some of them pull more, that some of them pull less. Then if you open 2-3 tabs, that in the end web transport doesn't work because they're competing to the same. But this is like a different. Yeah. Okay.
I see. Thank you.
Yeah.
Martin.
Point here is probably one that we need to pay a little bit more attention to. When I suggested that we just sort of do nothing, I hadn't sort of internalized that problem, but you can imagine how easy it would be to use up all of the streams. It's just a for loop with a create stream call, right? And you've used them all up. The streams are easy to create, but there's no guarantees about the number of concurrent streams that will be available to you at any time. Quick doesn't provide any real guarantees. HTTP2 has this sort of, you can have 100 concurrent streams or whatever the number happens to be, and you know what that number will be, but Quick, you only get new streams when the other side decides that it wants to give you some, and it could reduce the number of concurrent streams. So I think there's minimum guarantees, and I think there probably needs to be some sort of cap. The more that I think about this as we've discussed it, and it's coming back in.
I see. So it sounds like we have some ideas on how this should work. And I think we should discuss the rest on the mailing list, because I think we spent already like 20 minutes or so talking about this. But yes, this is definitely needs further discussion on probably mailing list. Thanks everyone. This was very valuable. Next slide. So the next issue is, what do we do with redirects? And there are roughly two options we have: to follow redirects or to not follow redirects, and the first is to the application. We had similar discussion a while ago in W3C, and I think back then we agreed that we should redirect to the application because that makes the stack just much simpler. But I wanted to know what opinions on this matter do folks in this working group have. So if anyone has opinions, please join the queue. If no one has opinions, I think I will just close with the W3C conclusion, which is we don't support redirects. David?
Thanks. Speaking as individual contributor and the person who filed this issue, I'm okay with that. I don't have a strong opinion on whether we should support it or not. I just think we should be very clear in the spec whether it is supported or not.
I see. Thank you. Martin?
Sorry, I'm going to have to refresh my memory on BCP 56 biz, but I think if we're playing HTTP, we have to play by the rules, and 3xx is one of the HTTP things that you just have to deal with. And so there are 3xx's that don't make any sense for web transport, but there are 3xx's that probably do. Can't remember which one goes where, but I think that if we're playing HTTP, then we have to not pretend.
Yeah, I can see that. From my personal perspective, and my intuition is roughly redirects are the things that people don't build in initially, and then when they don't build it, they end up regretting this. And I know that because I used to support a certain very ancient legacy protocol with a server that I needed to move. And I had to do really dirty load balancing tricks to move it because that protocol did not support redirects, which made it a lot harder. So I think we need to figure out whether we actually need to do redirects according to the BCP, and if that is the case, I do. We should support them, and if not, we should revisit this. All right. Next issue, and I think that's the last big issue we should address, is the issue of request forgery, and this probably is not a very good summary because Martin wrote much more, but basically in the issue is there are multiple forms of attacks that exist in which you can confuse a peer into in which you can confuse various parties into believing that you're speaking a protocol different from the one you're actually speaking. On one level, there is obvious attacks like the ones one of the reasons we don't give raw quick sockets to web directly is it allows you to bypass authentication. And whenever in web transport we go out of our way, and as a part of requirements, we have to identify that all of our traffic that is initiated by a web application is identified as being initiated by a web application as opposed to any native client. But there are also families of attacks that you can still perform. And one of them is the one WebSocket tried to avoid with masking, is an attack where you try to make your traffic from client to server look like certain kind of HTTP traffic. And that would lead intermediaries to assume that you're speaking HTTP, even if you're obviously not. And WebSocket addresses that by trying to make the traffic unpredictable via masking. And the question is, do we need to do anything similar in web transport or not? And I want to hear people's thoughts on this, especially Martin, since he filed that issue, and I'm not even sure if my summary is good or not. Martin?
It takes about 5 seconds for this to come through. So, Victor, the only thing that I'd probably correct in your summary was that the impersonation of another protocol is not just HTTP. You can make it look like other things, and I think one of the NAT slipstreaming stuff was using, I think, stun at one point, or SIP, or something else. It was a whole bunch of different loopholes that they were looking to exploit. So because you have essentially full control over the packets that are being exchanged between the client and the server, you can do a lot. I'm not. Yeah, Harold's much closer to this than I have. It was stun with special control over the UDP message fragmentation, which I don't think that Quick natively has, but it's worth considering. I have not come to any conclusions myself on this one. I was hoping that folks like Harold would be able to provide their insights, and I know Adam Rice has been doing some work on this as well.
Yeah, so the questions I would have, like, the first question I would ask is this specific to web transport, or if this is a problem, why is this not a problem with something like fetch?
It is a problem with fetch. Yeah.
Okay. Harold?
Yes, so the problem with masking is if you give the attacker control over basically the first bytes of a packet, then you can count on some idiot box on the network somewhere doing something inappropriate with it. So the reason why the Natch Slipstream attack worked was because Stun sent packets that were chopped into more than one UDP fragment, and the attacker had control over the first bytes of the UDP fragment. Now, if you encrypt content, then the attacker does not have control. And if you have a header that is controlled by the protocol, the attacker does not have control. So if you encrypt what the attacker has control over and format the rest according to your own rules, you're basically safe against forgery. That's the short version. Now, web transport didn't encrypt, so therefore they did masking instead. No, WebSockets, I mean. It's much better to encrypt, as Quick does.
I see. Thank you. Davis Kinaze.
Yes, speaking as individual contributor again. So encryption helps, but not in this scenario because it is predictable. The issue here is these attack setups include like a participating evil web transport server with, like evil web transport JavaScript on the client. And so even though we are encrypting, because we're using stream ciphers in Quick, you can have the evil web transport server send the keys over the application layer and the packet numbers it is receiving from the client. So the client can pick some packet number in the close future and then blast that a bunch of times because since it's a stream cipher, you can, if you know what the you can recover what the key mat is, so you just XOR your plaintext with that, and then you can have influence over the ciphertext. So you can defeat the protection brought about by encryption using this. So we still have a problem we need to solve, is kind of all I'm saying. But the next step is, how do we solve it? My personal take is this isn't specific to web transport. Like, you have the same issue with regular fetch requests. And so potentially the best solution is to do the same thing as what we did for the Slipstream attack, which was to add a few ports to the fetch TCP block list. So I think the solution here is that we need a fetch UDP block list of ports, which would solve the problem for regular HTTP requests and for web transport. That means that here, in terms of IETF, we would do nothing, and then we would kind of punt the problem to the W3C. That would be my personal put here.
Yeah, so I agree. One thing I will notice is, as far as I remember, web transport actually respects the TCP port block list. And the other thing is this will protect us against port blocking, will protect us against this NAT slipstreaming attacks, but that doesn't mean that it will protect us against all classes of attacks that we may not be yet aware of. Yutaka?
only for client to server direction. So server to client communication is not masked because the original scenario was the client attacks proxies living between the server and client. But given the scenarios for web transport, it seems the client to server and server to client both need masking. Is that right?
Well, to some extent, I don't think masking can help on server to client, because if server is malicious, it will do, like, the entire attack depends on the premise that both web application and the server are malicious, and it doesn't help you to require masking on server, because the server can already send whatever it wants. And the fundamental problem with this attack are the client to server flight, as far as I understand.
In that case, the masking sounds relying on an assumption that the server to client is safe, and it sounds unrealistic to me.
Well, it is not as much as safe as in there is nothing we can do about it, because the server can send whatever it can.
Yeah. I see.
I guess I'm not sure how this works out in case of NAS live streaming, but in general, the problem is where it is forging the packets that initiate from within network.
Thank you.
Thank you. Harold.
I kind of panicked when I realized what you were saying. Was it Vasily who said it about an evil server being able to leak the keys and thereby influencing the ciphertext? Because that attack will actually work against anything that uses quick. And that means that, well, first of all, it's a much bigger problem than I thought. And second, it's not this working group's problem to solve. The first is bad, the other is good for this meeting, but not for the ecosystem. If the attack is real, then it's applies to any protocol using Quick.
Yes, I think my intuition is that this is an issue we should probably punt to Quick Working Group, because this is extends far beyond web transport. And to some extent, this is a problem that can be addressed in various levels. But I don't think web transport is the correct level. Does anyone object to that conclusion? Martin.
Just a note, I think we're almost out of time on this segment, so we should probably, do we have any more slides, Victor?
No, this is the final slide.
Okay.
I was going to say, I only object to it to the extent that it might then not go addressed, if indeed we believe that it being addressed is necessary. But if we take the necessary steps to ensure that we have a discussion, perhaps in HTTP, perhaps in TLS, then I can live with that.
Thanks, Martin. This is all for my slides. I'm returning the mic to the chairs.
Okay. I think we're going to move on to Eric Kinnear with Web Transport using HTTP2.
All right, we should have audio. And next slide, please. So we've had quite a few changes since we last talked. If you may recall, at IETF111, we talked about moving to a layered design, which effectively pulls in kind of a minimal set of framing from Quick and runs that over a single HTTP2 stream, in large part because we were saying that it was easier to build something on top of HTTP2 than to own an HTTP2 implementation and expect those implementations to change. Martin has also graciously said he is willing to join us as an author and has been contributing a lot of nice text, so thank you, Martin. Next slide, please. So I drew a couple of fairly crude diagrams to kind of help us all page in what we mean when we talk about these things. So to set the stage here, I've got this box in the middle that we're going to worry about in a little bit later. But instead of adding additional frames to HTTP2, we now have an H2 implementation on either end. There's client, server, pick your favorite intermediaries. And we use extended connect to say, hey, I'm speaking web transport. And then that connect stream becomes the thing that carries the entirety of the web transport session. So when we've talked about kind of breaking out to use native streams or datagrams when they're available or something like that, this is kind of the far end of that spectrum where nothing is broken out and everything is self-contained within this single connect stream. Next slide, please. If we then move into what was inside that box in the middle, we have a web transport session where we have bidirectional streams. We also have unidirectional streams, and we also have datagrams. And of course, these can be initiated from either side, which is why I've got some of them kind of anchored on the left and some of them anchored on the right. But conceptually, what we're doing is we're taking a lot of the framing that we were adding into HTTP2 and lifting it up one layer so that it's effectively version independent. Next slide, please. In order to do that, we end up pulling over a subset of the frames that came from Quick, and we saw a variant of this slide at 111, and in actually writing up a bunch of the text and the definitions, there's a couple of issues that we need to work out, which we'll get to in a little bit, but in general, it was fairly clean. So there's kind of the main set on the left. You've got stream and datagram, and we also brought along padding. And that allows you to do, the bidirectional, unidirectional streams and datagrams. And then there's a set of reset stream, stop sending, kind of state management there. And then there's flow control, which is pretty much lifted exactly from Quick, which is subtly different from H2, but that's not the end of the world. So for that, we have max data for the whole web transport session. We have max stream data for a given stream, and then we have max streams for stream counts, and brought along the blocked variants of those frames as well for the same purposes as we have them in Quick. And next slide, please. So we've got a couple of issues that I wanted to bring up here so that we could kind of talk about them as a group and hopefully make some progress on unblocking kind of some of the remaining questions as we were specifying exactly where the different bits and bytes go. The first one is when we talk about mirroring Quick, there's kind of two pieces that come into this. And the first one is that there's a couple of fields in certain Quick frames, and I've pulled up reset stream as an example, that are just not necessary in the way that we're doing this. So for example, within reset stream, there's final size. And it turns out there aren't very many other examples of this. But here is an example of a field where both sides already know the amount of data that's gone on this stream. We don't actually need final size. It's not communicating anything that's interesting. And so the main question is we're talking about, hey, there's some additional lifting necessary in that you now need to parse a bunch of these frames. One of the ideas that was brought up that is potentially really attractive is, you could just reuse your quick parser for a bunch of these frames. And so rather than needing to do a bunch of lifting to handle all of this stuff, you could just say, hey, this looks like a quick frame, at which point we could just leave final size there and your parser would just do the thing and you just wouldn't bother looking at what's there. And it's a variable length integer, so it wouldn't take up very much space, and we could all move on with our day. We can talk about what our appetite is for that. If we go to the next slide, the other thing that comes up there is we've added a length field to every frame. That gives you a couple of things. One, it lets you take unknown frame types and be able to skip them. And you're packing all of these frames into a reliable byte stream. And so it's really kind of nice to have the delineations of where things are, especially since things can't be lost and you can't just ignore any of them. We've currently put that right after the type, but it is entirely possible that we could put the length first. And I think Alan had made the interesting observation that if we put the length first, you could consume the length, strip it off, and then shove the entire rest of what's there at your quick frame parser and be done. And so I think the place where we want to stop right here is to get some sense from people of, is this an attractive thing to do? Is this as somebody who's implementing this, you say, oh yes, this is, substantially easier if I don't have to do any of this parsing. There's a bunch of variable length integers here. I'd like to just take my quick code and, strip off the length and shove the frame at it? Or does this become useless and not actually particularly helpful? I see Martin has joined the queue.
Well, I was just going to point out that you could be even more clever than this and use the same length field for multiple frames, because that's what Quick does, right? And but I'm not sure that I really need to go there. This is the fallback protocol, and we can always be too clever. I kind of like the way that we have it in the draft at the moment, and I'm comfortable then saying that this is not Quick, and removing the final size doesn't make me at all uncomfortable.
I think that seems pretty reasonable. Lucas?
Yeah, like if you're going to change the frame layout, then you're not going to get any reuse from Quick unless you start to special case your Quick parser, which I wouldn't suggest anyone does. Like the parsing code for these things is like, if you have a length, it's pretty easy. It's not that hard to copy paste the code and call it a web transport frame parser or something. So I would just go for the simple thing and not try to be overly clever. Thanks.
All right, Alan?
I guess since this is my suggestion, I'll just say that I think I prefer like having I would either put the length first and keep the frame formats the same, and then just reuse the quick parser. I mean, yes, you can copy and paste it, but I think I would prefer not to. And I don't. And the other option we have talked about is that Quick itself doesn't have the lengths, and do we need them here? Do we want? I mean, the main benefit is you could add more. You could add unknown types, and that's why you have a length. Otherwise, you know exactly what's going to be in there. That's what Quick does. You can't add unknown types in Quick. So I think it's sort of bound together. We could drop length we could drop length entirely if we don't want to support unknown types.
Right. It seems like we're kind of walking into a binary decision of make it look like Quick, or it's okay that it doesn't look exactly like Quick, and we're fine with that. Ian.
Actually, I think ask basically the same question of like, do we really think we need a length here? Because yeah, I think, I'd have a slight preference for just like not adding a length and then like making it look like Quick, because it does seem slightly preferable to me. But and I'm not sure if I understand like why we care about skipping unknown frame types, but maybe there's some use case that I'm missing. So the other thing I wanted to this might pop the stack a little bit, but like at some point, can we get back around to, it looks like there's some functionality that on the session layer here that is per connect stream in HB2. And when we go back to HB3, like max data and such apply across all sessions, which we sort of alluded to earlier today. I'm not saying that either of those are right or wrong, but it does seem like the functionality that you're mapping over HB2 is offering is actually a slightly richer functionality when multiplexing than the HB3 version. Is that correct?
Yes, and there's an entire slide and section later we'll talk about this kind of, all of the questions we had earlier about pooling and flow control and all of those things are effectively gone when we talk about this, but we'll get to that in a little bit.
Okay, sorry to mess up your slide.
You're awake, it's great. Victor.
Oh, I just wanted to say that in general, length fields sounds like a great idea for anything that is not super concerned about the size, and we're not concerned about the size here. So it sounds good to keep length and remove the final size.
All right, David.
Speaking as participant, yeah, my general take here is that since this is the fallback transport, we don't need to squeeze every single bit of overhead out of it the same way we do for the quick transport layer. So having a length seems like a recipe for fewer headaches down the road. And once you have a length, this is then becomes a segue into your next slide, which is this is starting to look an awful lot like a capsule. And why don't we simply, bingo, thank you, MT. Why don't we just use capsules then? Because this sounds exactly like what you want to do. And as a wise MT once said, why have another frame type and another extensibility joint when you can just use a capsule type, and then we register whatever 8 capsule types for all these WT frames, and we call them WT capsules, and we move on. That would be my put here.
So I think, just to make sure I understand, you're saying make it a capsule, register it, don't worry about trying to make the types overlap with quick because we're doing a separate parser anyway. And so this is we're not super worried about making it look like quick, just make them be capsules and keep going?
Yes, that's what I would say.
Gotcha, thanks. Alan.
So the only thing I would say about capsules here is that I don't like all that is going to buy you is a parser that knows how to parse a type and a length and then give you a blob, or and go to a more specific, a type specific parser, which you have to have anyway. So I'm not sure that the capsule protocol, like that code, I'm not worried about either copying or pasting or templating or whatever. The parsing of the type and length. It's more handling the specific types, which I already have code for in Quick, and would rather just reuse that. That's a lot more code to copy and paste versus like getting out the type and length, or or if we decide we really want length, then length and type would be my preference. So.
Right, I think what we're deciding between is effectively length, then type, and keep final size, or type, then length, and cut final size. But it sounds.
Can I ask just one more question? Is final size the only field that is not the exact same as quick?
I'd have to double check when the sun is up, but if it's not the only one, there aren't more than 1 or 2 others.
Yeah, I mean, if it was the only one, it's 1 byte that you would be sending in an error frame. Like, I would just keep it the same, but other people will make different decisions.
All right, David?
I would just to echo what I have and I think MT have been saying on the chat, like given that there are like 6 frame types that all have like on the order of 2 to 3 fields on average, like reusing the quick frame parser sounds like trying to shoehorn something that doesn't fit. So I would very much push to like not have that as a requirement, and then just say we have a different encoding of the frames. Their semantics are the same, but we can have a completely different encoding. Like when it comes to processing these frames, like all the hard part is the stream logic, it's the flow control, it's all that machinery which you can reuse. The parsing is like 0.1% of your code size at the end of the day. So I would very much push to drop the trying to reuse the quick parser, and then things become a lot simpler. And it also avoids some kinds of confusions down the road when you have things, like final size or others that could, mean subtly different things.
I think that makes a lot of sense. So I'm hearing an overall lack of concern with having it not look just like quick, and that people think it's a reasonable thing if it's a little bit different. And that we sidestep any of the negotiation issues by having a length in there and can just keep going. All right, thank you all. Next slide, please. For our next issue, as David alluded to earlier, if we have this type and we're not sticking the length in front to try to do anything cutesy, the thing we were just looking at happens to kind of already be a capsule. And so effectively, my understanding of what we're doing here is saying, yeah, previously when we defined these frames, we used the exact frame types from Quick, but now we're going to just register them as capsules and keep going. So it sounds like this probably falls out from what we're doing before, but I thought we'd stop and talk about it just in case anybody feels really strongly one way or the other. So basically, assuming whatever's going on in mask, we resolve and come to a adequate consensus on for where HTTP datagrams are going, what this will end up looking like is you make this connect stream and then you start sending capsules, which are effectively just the web transport frames that we've been defining. And we're just going to say one capsule is one web transport frame. Effectively, types are kind of in this more shared place, but otherwise we're good. And then the other question there is, do we make web transport datagram be its own thing, or do we just use the actual datagram from HTTP datagram land? And I see Alan is in the queue.
I mean, I'm not sure what the value capsule brings here. Even if the format is defined exactly the same, it now means we have to register the types for this protocol in a global place, when I don't know that it's not like some other protocol is going to want to parse these frames in their capsule handling, nor would we really want to handle their capsules in ours. So even though they look the same, I don't think they need to be the same. And if we were saying that it's no big deal to copy and paste your quick parser, then it's definitely no big deal to copy and paste your capsule parser.
And there's one other thing that comes up there as well. We had some interesting conversations around capsules and intermediaries, but we're doing all of this over a connect stream already. So David's in the queue.
Well, so I mean, not to open up the capsule discussion that we are having in Mask and that we will be having as part of the Mask HTTP datagrams design team, but in general, I think a lot of this comes down to what your plans are for getting across intermediaries. If at the end of the day, for let's say, if you have like an H2 to H1 through an intermediary, if you're saying that web transport needs to be done, re-implemented on each hop as opposed to it can go through intermediaries seamlessly, that kind of changes the outcome here, because capsules gives you the justification and motivation for having capsules as a shared infrastructure layer is the idea that they go through intermediaries just unchanged simply. And so that way, if you get on that bandwagon, you use the general capsule registry, so you don't need to have your own IANA registry, which saves some work there. And then they just, you put them in your stream, they get across to the other side. You don't need to worry about things like intermediaries. But, that comes down to, if we instead say web transport needs to be re-implemented for each intermediary, especially between H2 and H1, then that is a bit less attractive.
So clarification question there. We're not talking a whole ton about H1 specifically here because we've been continuing to focus on H2 to keep from expanding super rapidly as we type all this in. But if I weren't using capsules and I sent connect to an intermediary that then was doing H1 to the backend and it made a ostensibly TCP connection somewhere and started sending my web transport frames, are you saying that's meaningfully different if we call those web transport frames capsules?
The meaningful difference is that so first off, you're right that like if we're just focusing on H2, it's not as important. But I guess, if H2 to H2 with an intermediary in the middle, it's if you're using capsules and I'm waving my magic wand and we have defined a generic capsule thing where you tell the intermediary with a simple way, oh yeah, this is a capsule protocol, then I will just be forwarding these to the corresponding connect stream on the upbound connection. Then you get that forwarding property for free. Whereas if you don't, then you need a more web transport specific handling at that layer.
Thank you. Okay, we can also have this sit until the design team in mass comes out, which is probably something we're going to want to do either way. Alan.
To add a quick note on that, our goal is to have that mass design team happen very soon, like most likely next week. So just this would be a small delay, and I think that makes sense. Sorry.
Just the last thing I want to add here is that what you're describing, if I need to get the bits from, I don't want to participate in this thing, and I need to get the bits from one side to the other. That is already free because it's on a data stream. And that's what intermediaries do, right? They take data from one side and they put it to the other side. And they're not participating anyway. They're not parsing these things. It's fine. The only reason they would ever need to parse them is if they were actually participating in the protocol, in which case they have to understand it anyway. So again, I don't think, the only thing I think bringing a cap, even if they looked exactly the same and you overlaid capsules here, all that would mean is we need to register our type in some other global type. And then I don't know, not sure why we care what our type numbers are, but like we have this sort of global registry of things that can never appear in the same place.
All right. So it sounds like we're going to sit on this until we hear which way we're jumping over in mask either way. But let's take some of this discussion onto the issue and see if we can actually write down, I know some of what you were just saying, David, might be worth putting in the issue so that we have, something we can refer to later as okay, here's the kind of concrete difference between these approaches. All right, next slide, please. So this is where we start getting into some interesting questions where eventually we'll talk about this with HTTP3 as well. So right now, as I was saying a minute ago, we're kind of at one end of the spectrum in that we've pulled all of these things into that connect stream. So there's the sequence of data frames that is this web transport session. And the lifetime of that connect stream, wherever you are on the spectrum, is going to determine the lifetime of this web transport session. But we have retracted everything back into that connect stream. And that makes a whole lot of things fall out rather nicely, like flow control becomes fairly elegant and a bunch of other stuff. Pooling is a non-issue. There's all sorts of things that are nice about that. But part of how we got here through what we've been calling the web transport framework is effectively that, we can have a fallback or something like this, but we want to be able to use the native implementation of things. The example here being HTTP3 with HTTP3 datagrams. We want to be able to send actual datagrams when we're over something where the transport does have support for that capability. So when you pack your web transport datagram frames into your H2 data frames and send them on your connect stream, they're not actually unreliable. They can be unreliable when they get somewhere and flow control has some interesting lack of application, and so they may be dropped, but they're not going to get lost in a lost packet that is not retransmitted. So with that said, H2 does provide native streams, and so if you take all of our words and don't really think too hard about it, you could assume, okay, well, if there are native streams, even if there aren't native datagrams, then we should split out every web transport stream into a native H2 stream. And the last bullet on this slide kind of goes to where we are right now, which is we didn't actually do that because there didn't seem to be significant benefit from doing so. So if anybody feels strongly that we need to do that, now would be a time to speak up. But unless somebody can see a significant benefit for us doing that, there's obviously benefit for doing that for datagrams, but for streams themselves, it doesn't seem like it really helps one way or the other, and there's all sorts of nice benefits to having them inside the Connect stream. All right, we'll take that as a happy moment. Next slide, please. So we have an issue in GitHub, and I think this is one of our last ones here that we're going to talk about, but we have an issue in GitHub to write up kind of how flow control works with this whole thing. And so I wanted to just kind of talk through that and make sure that everybody's comfortable with where we think we are and how this is going to interact with some of the pooling. So you end up with 4 nested layers of flow control, which is rather a lot, but does mean that each concept and each kind of scope, if you will, gets its own level of control, and you can do exactly what you want. So I drew a picture for this on the next slide in case it's more interesting. So if we go there. So this is kind of the diagram from earlier, but I squished the 2 of them together. And if we advance one more slide, I added some pretty colors. So you effectively have flow control where there's, the H2 connection that's governing everything across all of H2. That's useful for saying, here's how much you can send across all web transport sessions that are going on. Then there's the Connect stream itself. And so that one, contains an entire web transport session. And that allows you to limit the amount of data for that whole web transport session. And that's especially useful when we talk about pooling and things like that, right? So those kind of outer 2 boxes are the things that allow you to have multiple web transport sessions and express the relationships between them. Then the next 2 colors are within a web transport session. You have the kind of overall session level flow control, which is analogous to what Quick is doing, or a little bit like what H2 is doing, which allows you to control the total across all of the web transport streams. And then each stream obviously has its own flow control. So that ends up being a lot of flow control, but with all of that possibility to potentially screw things up, you also have the ability to control all of these relationships between the different things, and you can have multiple web transport sessions and they can all be pooled, and you have limits on the number of streams that can be established, both within web transport streams and within H2 for the Connect streams. So without a whole lot of extra effort or anything like that, kind of the existing model that you're using for H2 and for Quick applies respectively here. And much of the pooling questions become moot, and we continue on our merry way. So the current proposal here is we're going to write up a bunch of text that describes how this works to help people go in eyes wide open and make sure that we avoid any of the kind of common pitfalls. But unless folks have strong objections or feel strongly that this should be different, it seems pretty workable. And in the absence of anyone in the queue, we'll take that as being workable. All right, next slide, please. So we have an issue on GitHub for doing some error handling, to which the initial response is, yeah, we should probably do that. So the existing draft, we did not import all of the error handling from Quick that goes along with these frames. And so we have kind of an outstanding item of we need to import that over, but we wanted to talk a little bit about the shape of how that should look. And interestingly, we had a conversation in H3 earlier this morning about go away and some of that for non-error cases. Next slide, please. So we could bring along a go away here. We've got a way to reset individual web transport streams already. We've brought those frames over. So effectively, we could pull over the closed web transport session capsule. This is the one from H3. We could just bring that over and say it looks the same in H3 as it does in H2. There's a bunch of different ways we could shape this. So the real question here is, do we want this to look just like we do in H3? Do we want to borrow things from how H2 handles some of these things? Where do we want to go? Alan.
Yeah, I mean, this may also depend on where things go with Capsule. So whether or not we want to reuse that thing. So I don't know.
I think that makes some sense. If we're sharing capsules with H3, and especially if we start using these capsules over H3 in some cases, the benefits of sharing those goes up significantly. Ian?
Seems like this, the same question is very relevant to the HP3 mapping. So as much as possible, shouldn't we make sure our answers for the two are similar, or should they not be similar? And I don't know. Yeah, thoughts?
I think that makes a lot of sense. I don't have any strong reason why they shouldn't be similar, which in my mind is usually an indication that they should match. Martin.
That you want to signal here. One is that things have gone poorly and you want to tear the whole thing down, which is the thing you send before you close the stream. And the H3 web transport thing already has that. We should have the same thing. And if we're using the same format, then we should use the same message. Just makes it easier to forward these things, right? They're end-to-end signals. Again, the same applies to the go-away discussion that we had previously. So let's work out what the requirements look like, see what Alan comes up with respect to go away, and then we'll take it or not.
I think that makes a lot of sense. So we're going to effectively import whatever we end up doing in H3, and our discussion earlier was super relevant to this. Victor.
Slight question about the slide. What does mean web transport over H3 shares error space with H3?
So there's some text in the H3 document right now, or at least the version I was looking at when doing some of this, where we take a error code and apply a transform to it to be our actual error code, because we needed to put those errors in the same registry and space as the other H3 ones.
So no, this is a different error code. This is for resetting streams, not for resetting the streams inside web transport. The closed web transport capsule is for resetting the session.
Yes.
So I guess the question I would have is, does this issue cover both streams and sessions? Or
that's that's not something that we've been super clear about, but I think the short answer is yes. We need to be able to remove a stream, and we need to be able to say, this is very bad. You just did something that doesn't align with the spec, or broke a requirement that I had, and the whole thing is over, and we're not going to be talking anymore. So this issue, I think the original intent of the issue was for the I need to tear down the session, but we need to have the ability for people to do both, and we've got that pretty well spelled out, I think, for streams. But obviously, we shouldn't jump in one direction strongly for streams and a different direction strongly for the session.
Okay, it sounds like I need to take a closer read on the issue. Thank you.
All right. So it sounds like we're going to see where we wind up for H3, getting rid of the whole session, and then import as much of that as we can, which seems totally reasonable. All right, next slide, please. This is our overall discussion of any H2 things. Assuming that there's nothing major that anybody wants to bring up for H2 specifically, we can move on to the next bit. All right, so this is kind of the last section of this, which is, I think, what Ian was alluding to earlier. Next slide, please. So part of what we just did in moving to this more layered model, where we're using web transport frames on top of HTTP2 rather than adding additional frames into HTTP2, is we have now defined a way that you can use HTTP semantics with ostensibly any HTTP version, not just HTTP2, to communicate via web transport frames with the other side. And we've talked about how that works really nicely with flow control when everything is kind of retracted back into that connect stream, or that connect exchange and message. And we've also talked, but not actually done, a lot about being able to split out to use native features like datagrams in H3, and maybe not doing that for streams in H2, but you might choose to do that for streams in H3 because you wanted some of the benefits that H3 provides around, blocking between streams and that sort of thing, which doesn't exist for H2. And so the question we come back to is, should all of the mappings of web transport be doing the same thing? In other words, should this be the generic set of web transport frames that you can speak, and H3 might break those out into datagrams and streams and otherwise look very similar to what it does today? But should that be a version independent thing? And if we go to the next slide, please. Tried to capture a little bit of why we might want to do this or why we might not want to do this, but I think there's kind of two things going on that are a little bit in conflict. One of them is that if you are going through an intermediary, being able to do this, using HTTP semantics to talk to the remote end allows you to ignore much of the pooling questions. It allows you to go through an intermediary really nicely because you're just sending web transport frames. In H2, you're just sending those inside of data frames. But that your intermediary can go from H2 to H1 to H3 and back again, and you don't really need to care. I mentioned already, pooling becomes much less of an issue because all of the limits about how you handle streams are fine here. But then there's also some drawbacks to this approach, which are, if you've retracted everything inside of this connect stream, pooling isn't an issue, but that's at odds with splitting out datagrams and splitting out streams. And if you split out the datagrams and you split out the streams, now you have to deal with the pooling for them again. And the real thing that I think gave a lot of folks pause is, how do we negotiate which one you're doing? Like, if I'm implementing H3, do I suddenly need implementing web transport over H3? Like, do I suddenly need to be able to handle web transport frames coming in on a new H3 stream and on the original connect stream that's carrying the lifetime of the web transport session. And that's kind of annoying. And like, could the same web transport session do some things in one place and some things in the other place? Or do we negotiate that, like, I'm doing this in this mode? Where do we want to go from here? So I believe the next slide is just a discuss slide. Yeah, so if we go back one, just so we have our kind of pros and cons things. Where do we want to go with this? Like, we don't have to touch H3 at all, but there is some architectural elegance to having the same thing that is version independent, and the mapping of it onto H3 provides these native capabilities. And it happens to solve a number of other issues. So I'm going to hand over the queue and the mics to the chairs here, because I think this is a little bit larger than H2 and something that we need to talk about as a whole group. So I think Martin.
Yeah, just a time check. This is the remainder of the session now.
Yes, the chairs will want to save like on the order of 5 minutes at the end for wrap up, but this is the rest of the discussion that we were thinking of having today.
Sure. This is a great discussion to be having. I think that we should be talking about this. So thanks for bringing it up, Eric. I raised an issue on one of the repositories today on exactly this topic. I think it'd be really nice if the protocol that we define here could go over HTTP3. But I think it's also a reasonable position to say that if you've got HTTP3, then you must use datagrams and you must use the native quick streams for transporting the datagrams and streams across that connection. Simply because it is much easier, and also because it provides the sort of performance guarantees that we're looking to provide from the protocol. This really does exist primarily for the purposes of integrating with the quick capabilities, and not just sort of serializing everything, which I think might have some surprising consequences for things. But I do think it would be nice if the protocol was defined as the one protocol with the HTTP3 draft effectively just describing the way that the streams and datagrams are lifted off into those native capabilities.
My take is that we should not require servers to implement web transport over H2 if the only protocols they're interested in is web transport over H3. And the reason for that, there are servers that would be only interested in web transport over H3 or web transport in general if they can rely on quick performance guarantees. And because of that, that would mean they're not really interested in other versions of web transport, and this would effectively require them to implement twice the code. That's my opinion on this matter.
Yeah, I also, if we're allowing, if they're the same protocol and H3 receives the frames that are only allowed on H2, then it has to have sort of error checks to like say, no, you can't send WT stream. This is H3. Sorry. I mean, and except for so right now we would only have one shared message between what you can send on the H2 connect stream and H3, which is the closed web transport session. Maybe they'll go away. Maybe we'll come up with some other shared things that don't map to any like native H3 semantic. But I'm inclined to say that they're different, and you can't. I mean, you can't speak those H2 frames over an H3 connect stream, and we should just make it not possible to do so.
Yeah, I think that could make some sense. Martin's proposal is kind of attractive, which is you could almost do a slightly modified version of that. You could almost do the same, or at least where they overlap the same set of things, but require them to be split out into streams and require them to be split out into datagrams when you're operating over H3. And I think that would address Victor's point, which is at that point, we wouldn't be asking people to have to implement both. You would implement one thing, which was, this is how I speak web transport over HTTP semantics. And if you chose to only support H3, that would be totally okay. You would send those things over HTTP3 streams and over HTTP3 datagrams. And if you chose to also support H2, you would take effectively the same things and bundle them up in a connect stream in data frames, and you'd have that for free. But we wouldn't be asking people to actually support two things. I think architecturally in words, that sounds really nice, but in practice, Alan just pointed out, it isn't a 100% overlap, because a lot of the things that we're trying to provide with the web transport frames over these data frames in H2 are things that are already available natively in H3 anyway. And so, we could write a lot of text about how that's kind of a null mapping and it's all really the same thing underneath, but at that point, we're just calling it that because it sounds nice. They could just remain separate things that don't actually overlap. And I don't know that that would upset anybody.
So conceptually, the way I see web transport is the overview draft is called Web Transport Protocol Framework, and what Web Transport fundamentally provides a model of how you interact with a remote server, and that model is fundamentally based on QUIC. That is to say, my idea of how this works when I started writing the Web Transport overview and Web Transport over free draft when we first adopted was that there is this model of that Web Transport has streams and datagrams, and then Web Transport over HTTP3 and Web Transport over HTTP2 are implementations of that model, but the level of abstraction is not on this frame remapping, which is just something that kind of naturally emerged for those two use cases. But the level of abstraction is fundamentally the streams and datagrams model. I think there is a value in that, because this is on some conceptual level is a very clean model.
So I think if we said that you weren't allowed to speak the H2 version over H3, the feature you might lose is if for some reason you had a client that was talking H2 to an intermediary, which it must have advertised web transport over H2 support, but it didn't really want to go to the trouble of looking inside the data stream. And it's speaking H3 upstream to a web transport capable H3 server. So now that proxy has to do the translation. It's kind of what Martin pointed out in the chat. Like it has to parse that data stream and pull all the things out and translate it for that upstream H3. But I think that the converse requirement would be like the proxy can be dumb and the server has to do it is probably worse.
So my fundamental argument is if we are talking about cost to the proxy versus cost to the server, I would focus on offloading the cost of the server because the servers are typically individual web developers. And part of the reasoning behind the web transport effort was making life easier for them.
sounds like what we're saying is that we're totally okay if these don't look like the same thing, and we'd let any intermediaries have to deal with translating between the two, and pooling works great right up until your intermediary because you have a bunch of different connect streams, assuming that H2 is the leg that faces the client, and then upstream, depending on what's going on with pooling there and how we choose to solve that in H3, it's possible that the intermediary needs to make multiple H3 connections upstream. And vice versa, you could have a client that's speaking H3 to an intermediary would make multiple H3 connections, and then those might be shared over a single H2 upstream, which seems not unlike how we do other things.
Just one thing that brought to mind is that the stream limits can just be different on different sides of this things, and this is not an H2 to H3 specific problem. It exists even with pure H3 or pure H2 intermediaries, and it was sort of it was true in H2 sometimes with push, where you'd have like an upstream server that was allowed to create a push stream, but then the downstream session didn't have any push streams available, and so you kind of had to handle this case. But it might be sort of hairier in web transport, where it's not directly related to this issue, but since we're talking about intermediaries, it's just a potential mismatch.
Right. Thanks, Eric. Bernard, could you go to the chair wrap-up slide, please? Yeah, well, we have 8 minutes left. If someone has something that they think could be useful to discuss in under 5 minutes, they should come up now. Otherwise, we're going to wrap up and give some time to roam the hallways and eat some extra cookies. So thanks everyone for coming to Web Transport. We had some good discussion on quite a few issues. We do realize that we are a bit blocked on the mask work. Yours truly will work hard to resolve that as quickly as possible. But otherwise, yeah, thanks everyone for coming. We're making good progress, and we're looking forward to having this in a shape where we don't move quite as much. Bernard, any other words you want to add?
Yeah, just to note that Web Transport is available now in Chromium, so you can actually, this isn't just an academic discussion, you can actually play with it. And in particular, some of the quick media over quick stuff, we have all the APIs now for people to actually build things. So it's not just an academic exercise. It's out there.
Yep, definitely. Spencer, go ahead.
I just wanted to say that James and I have had pretty close notes to the discussion, but if people could take a look at them and see if we're massively misquoting anything, I think we have question marks on everything that we didn't get, and there's only about 2 or 3 of them. But I just wanted to let the chairs know that.
Okay.
Cool. Thank you, Spencer. All right, and we wanted to especially thank Alan for the jabber scribing, which wasn't required today, but thanks for keeping an eye on that. And thanks also to James and Spencer for the work on the minutes. I've been keeping an eye on them, and they look absolutely great. Thank you so much for taking the time to do that. We really appreciate it. Okay, that's all, folks. And we'll see you on the mailing list to keep discussing these issues. Otherwise, see you in March at the next IETF if we don't have an interim before then.
Okay, thanks everybody.
Bye.